Welcome to VHDL tutorial. Today we will discuss the packages in VHDL. Packages are concepts introduced in VHDL allowing reusability and sharing of code across different design units by providing a modular storing mechanism. A package can be defined as a collection of components, functions, procedures, data types, and other design units stored conveniently in design libraries so that any piece of code required by any design unit can be called and reused from the stored modules instead of required to be rewritten every time. For example, XOR gate is defined and compiled as an entity. Now, a half adder, a full adder, and a parity generator circuits need to be designed separately using structural style of modeling. All the three entities to be designed require XOR gate as a component. Instead of writing code for XOR gate for each entity under design separately, a user can write, compile and store XOR gate design in a package ABC, and any entity which needs to use XOR gate can simply include the package ABC as shown in figure and use it any number of entities to be designed in different design libraries. So here in this figure, a package called ABC. This module represents the package ABC. A component XOR gate is defined in this package. So the XOR gate resides in this package called ABC. We have some entities like half adder, full adder, and parity generator. So all the entities, the half adder can use the XOR gate component, and the entity full adder can use the XOR gate component by calling from the package ABC. Then also the entity parity generator can also use the XOR gate from this package. So the packages allow reusability and sharing of code across different design units. Then every package consists of two parts: package declaration and package body. The package body is optional. So here is this syntax of package declaration. Then package declaration starts with the keyword package. Then package name is. All the declarations are written in this section. That means subprogram declaration, type or data object declarations, component declarations, then constants or defined constants declarations, then attributes, then aliases, then use clauses, then end name. The package declaration should be end with the name of the package. Then next section is package body. This section is optional. Then all the definitions are written in this package body. Then here package body starts with the keyword package body, then name of the package, then is, then deferred constant initialization. That means if we want to initialize the value of a constant later, then it is called deferred constants. Then local declarations if any, then subprogram definitions. The definition of functions or procedures can be written in this package body, then end with the package name. So this is the syntax of package body. Then package declaration defines the interface of the package. Every package is identified by a unique user defined name. It is a declarative part of the package which can contain subprogram declaration, types, objects, components, and so on. And all the declarations in the package body can be shared across different design units, even in different design libraries. Then package body is optional and is needed only for those packages which contain any defined constants to be initialized, then any subprogram to be defined, or any local declarations. Then package body shares the same name as package declaration. with which it is associated. If package does not have any defined constants or subprograms, no package body is needed. Also, local declarations are allowed in a package body, that is, the scope of these items, signals, types, subtypes, and so on declared inside the package body is limited only to the package body, unlike the declaration in the package declarative section, which have scope across different design units using it. Then let us see an example of simple package. So this is an example of a simple package. We have the library IEEE, and this is an example of a package std underscore logic underscore 1164. It is a package residing in IEEE. So in this statement we are using the package std underscore logic 1164. Then how to use this std underscore logic 1164? So we can use this clause use IEEE dot std underscore logic 1164 dot all. So this is an example of a package. Then package new package. Here the name of the package is new pike. Package is a keyword, then name of the package, then is, then the two declarations, type word size is std underscore logic underscore vector 7 down to 0. Then type mem size is array 0 to 31 of word size. Then end new pike. So this package represents a memory. So this package represents a 32-bit memory with each memory location can store 8-bit data. In the above example, a package new pike is declared which contains declaration of a data type to create memory of 32 words with a word size of 8 bits each. Since the package contains only type declaration, there is no need for package body. Let us see an example to create a package with a declaration as well as package body. So here another example contains a package with the package body. So here the header files are present, library IEEE and use IEEE.std logic underscore 1164 dot all. Then starting with the package declaration, package keyword, then package name is comb underscore pike, component pike is, type state is abcd, so value of state is a b c and d. Then function, here this statement represents the declaration of the function edge detect. So function edge detect signal x std logic. The arguments here, only one argument is present, signal x. Return boolean. The return type of the function edge detect is boolean data type. Then constant m integer. Then end component pike. So that is the end of this package declaration section. Then we will start the package body, starting with the keyword package body. Then package name is component pike, then constant m integer is equal to 5. So here the value of constant m is equal to 5. This is called a deferred constant, means we have created the constant m in the declaration section, but we initialized the value of the constant m in the package body. So this is called a deferred constant. Then this is the function definition. Function definition start with the keyword function, then function name edge detect, then signal x std logic, return type boolean is, Then another declaration, res. Res is a signal of type boolean. Then beginning of the function. Then next statement is if x event and x is equal to 1, then that means x represents the clock signal, x event and x is equal to 1, then res is equal to 1. Then else if x event and x is equal to 0, then res is equal to 0. In this function the signal x is a parameter, so here the signal x represents a clock signal. Then if x event and x is equal to 1 means if clock event and clock is equal to 1, that means the rising edge of the clock, then res is equal to 1. So res is equal to 1 in the case of rising edge of the clock. Then if x event and x is equal to 0, then res is equal to 0. Then end if, then return res, the value of res will be returned. End edge detect. So this statement end edge detect represents the end of the function edge detect, then end component pike. Then next topic is how to use a package using package. The items stored in the form of packages can be reused anytime in any design unit by including the package containing the required items in the entity under design. VHDL gives the additional flexibility to include only the desired item from the package in an entity under design. To include only the desired item from the package in an entity under design, or the complete package with all its items included in the entity under design. This helps to save on the memory resources at the time of compilation and simulation by including only the required item from the design unit. By default, any package made and compiled is stored in the design library work. By default, any package made and compiled is stored in the design library work, which is a default user working library. So you should note that the work is a default user library, and any design unit which needs to use the part or all of the package items need to include the package in the design unit with the use clause having the following. Then how to use the use clause? Then this is the syntax. Use keyword, then library name dot package name dot component name. So this statement includes only the named component from the package. So here if we want to use a particular component only, then we will use this statement. Use library name dot package name dot component name. Then next statement, use library name dot package name dot subprogram name. If we want to include a subprogram from a package, then we will use this statement. That means use library name dot package name dot subprogram name. Or if we want to know, if we want to use all the components, packages, etc. from a particular package, then we will use this statement. You use library name dot package name dot all. Here we have already used this statement in all the programs. For example, use IEEE.std logic underscore 1164 dot all. Similar to this statement, use clause then library name. Library name means here the library name is IEEE. IEEE dot package name. Package name means std logic 1164 dot all. Dot all means we include all the items from the package. Then library name is the name of the design library in which the package is stored. By default, it is a work library but can be any other user defined library too, followed by the name of the package name, which has to be used, followed by the name of the component or item needed to be included, or all if the whole package is to be included. So That is the end of this topic, packages. Thank you.